Welcome to my talk. Thank you to Artyom for having given a very nice introduction. And maybe some of you have come to my talk before. I spoke at DevOps Ukraine and also a couple of meetups too, as well as the Geeko conference too, all based in Ukraine. So I'm very happy, and I actually visited your country a few times. If you are aware, have been to some of the Java users group. I was there. Actually, Oleg the Huka helped me, and we did a talk together. So if you've been there, thank you, and for coming back too. So at the present moment, actually, I also switched company. I'm with DataStax now. The company that actually is the flagship product is the Cassandra, the managed Cassandra cloud platform. And about a year and a half ago, they also incorporated event streaming platform, which is using Apache Pulsar. So my talk now is actually going to be focusing today, right, on event streaming and processing with Apache Pulsar. As such, it is still very open source kind of in nature, and that's kind of my advocacy too, is for open source type of systems. So okay, so without further ado, I know we're time is short here, so let me start. But first of all, I want to let you know I stand with Ukraine, and also my Chicago Java users group too. We all stand with Ukraine. We continue to do so. And also, if you're interested in this slide deck while I'm doing the presentation, you are welcome. I'll leave this up here for like 30 seconds if you want to take a quick, kind of a camera shot of the QR code, or take screenshot of the Bitly link too. So if you want to do that, you're welcome to do so. I know that sometimes folks like to follow along and look at the slides, also look ahead too. So feel free to do that. Even if you miss it, don't worry. I'm going to be sharing the slide deck with the organizer here. So. Okay, so let me move on. So who is Mary Grygleski? Who am I? So thank you. I won't say as much now. Artyom already did a great job explaining, but I wanted to point out again that I actually was an engineer for over 20 years before becoming an advocate. So I thoroughly understand sometimes too, what you're going through if you're a developer for big corporations, for, you have to do a lot of support, right, to doing like production type of support work. I've also done that. So I kind of certainly can understand, and also I appreciate too having that background, and it helps me now to do advocacy. I kind of can speak to all of you. So, and then those are the links as to how you can reach me if you haven't already connected with me. I also have my Discord channel too. So if you want to join me there, I love to continue the conversation, and I invite you to share with me all your projects and ideas. And I have actually folks that come to me continuously too. So, and I enjoy that. And this one is just a slide about my currently, kind of more pictorial format describing myself. And again, if you miss any of these, I'll be sharing the slide decks, or you already downloaded it, you can get to me. You know how to reach me. Okay, so today's talk essentially too is about event streaming and processing. But as I'm kind of getting deeper into this topic area, I think a lot of folks, a lot of you too, and as we know, it is becoming the thing, right? People everywhere are talking about event streaming, event messaging, or messaging, distributed messaging, and all these things. And they seem to be used like interchangeably. So the thing is too is that I understand sometimes, at your workplace, you may not be using this approach yet in your systems, or if you're using it, perhaps it's only a tiny bit of it, or, not like a full picture. So I feel that it is kind of necessary for me to kind of set the stage and making sure we all understand this topic, from the same page, essentially, and also clarifying some of these in terminologies too. So I want to spend a few minutes too. I hope it's okay with some of you if you're already familiar, right? To kind of step through some of these basic concepts, to clarify them, and kind of, differentiate about the different, references to this topic area. I mean, there's just so much stuff to it too that I cannot simply kind of squeeze all of them within, 5 minutes. But let me kind of still step through it and kind of set the stage, make sure we are all on the same page. And then after that, I will be basically discussing as to why event streaming is important, right? How can it improve your systems? And then I will introduce to you Apache Pulsar, which is an open source Apache project, and a bit of history about it and what it is about and what it can do and the promise that it can have. So it's very exciting. Then after that, essentially telling you why Pulsar, right? So that's kind of essentially what I will be talking about in the next 30 minutes or so. First of all, then let's start, right? The many facets of computing events. So if we talk about events, right, I like to kind of set the stage first. What is an event, right? Generically speaking. I mean, as such too, I actually been to different many conferences and also submitting proposals. And it's interesting too, is actually quite recently, maybe 6 months ago, submitted to this. I got invited and then I submitted there and I proposed like event-driven messaging and processing, right? This topic. And then the organizer, who actually was not familiar, in fact, the person was not actually a computer person, and that lady actually was asking me, "Oh, event, you mean like, people get confused, I should say. Basically, we're saying that events, you mean like a music concert, an event, and so to me, I feel that it is necessary to set the stage, kind of understand kind of from scratch what it is first and why are we using the word event. So generically speaking, right, it doesn't matter if you're talking about computers, you're talking about music events or sports events and all these things, but what is an event? So I look up Merriam-Webster dictionary, the .com, and essentially too, the first one sums up everything. It doesn't matter what subject area you're referring to. It basically means it's something that just happens. It's an occurrence. So, then there are other definitions for this word. But the fourth one, I find it to be most relevant for the, area that we are involved in, which is computing, and is from the theory of relativity. So that actually means an event is basically, if we want to boil down, what it boils down to is really the fundamental entity, right, of observed physical reality. So event is abstract, right? So we can't see it. But let's say we kind of put it into a physical reality, then we use, if you're a math person, there's the place, we describe XYZ coordinate is basically in space, that point in time. So that's the event. Now, the thing is with event is that we also add in a fourth dimension, which is the time. So essentially two events, that a point that occurs in time. But as you know, right, this time, the time that we are living in, it's continuous and we can't kind of roll back too. So it's kind of a continuum kind of this time kind of dimension. But we basically then have the events there. Now, that's abstract, right? It's more like about the theory of relativity. And so in terms of computing, right, you might ask, it's like, why do I bring this up? Yeah, but because it is exciting. I think exciting in the sense that we're dealing with events that are happening continuously and we need to track it. And it carries with it some data of, kind of value to us and whatever that is, right? Some data can be in any other form. And these events carry with it data. And not only that, right, it changes too. The state keeps changing over time. And not only that, right, it gets more complicated because we live in a complex world. It's not just one event every day. We know that as human beings, we have many things happening at the same time. The important thing in computing these days, all the research is to figure out how can we process events, concurrently, asynchronously, and they are all kind of not stepping on each other's toes, and that's the important thing, and not missing anything, all of these things. So essentially two events, and that's what we're dealing with, like events driven computing, all of these things. And it's not just one event, many events, and can be many other things that are happening at different times. They actually need to be all correlated with one another to make sense out of it. So that's essentially what it is. Now then, let's kind of move on a little bit about event streaming processing, right? So that's the title of this talk. Basically, that really is referring to the practice of taking action of a series of data points, right, that originate from a system. The system will continuously produce data events and all of these things. So event is basically, again, refers to each data point in the system, and the stream is basically refers to an ongoing delivery of these events, right? So the stream is, it doesn't matter, it's just, can have different points that comes out, and they occur, at different times and all of these things. So a series of events can basically be referred to as streaming data or data streams, right? So as such too, there's the computing side of us, processing data as streams of these things, but that can also be media data, right? Audio, video, if we're kind of referring to, like, you stream your movie and things like that, they are all data, but there are tons and tons of data happening, and kind of produces, gets rendered onto the screen, the sight and the sound and all of these things to kind of produce a movie. So that's also like streaming. So without explanation, we all know what that is. Now, the thing is that there's also, in computing side, there's also these concepts of complex event processing. Now, it is, one thing is, all of these data coming together, all of these messaging, all of these things, but they won't kind of do anything for us if we don't actually use it for something useful, right? To derive some value out of it. So complex event processing is essentially to dealing with these complex events, right? As such, the name implies, is a set of techniques basically that will help to not only capture all of these events, we also do analysis of these streams of data as they arrive, right? So the purpose of such is to identify opportunities or threats too. Like very often too, we may want to do like a fraud detection system, right? I'm sure that you have bank accounts, that you have online access and all of these things. And all of the banks these days, I believe they should, right, have all of these fraud kind of detection on all of these, detecting any kind of unusual kind of movement to it. So if there's some change of state of some data, for example, like they can, you need to have systems that are kind of tracking if the account get debited, but somehow the source of the action came from a place and IP address that's unknown, that hasn't been reported to, then your a good bank account, the service should immediately notice it and then send you a notice, an alert right away, and say that, well, we detected like $100 being deducted from your account. Can you check to make sure it's you and confirm it, right? So some of us, I'm sure you have already, kind of received this kind of alert messages. And actually, in my case, right, there are also my credit card too also got kind of somebody stole the number, and then I got immediately notified too, that says that, please check. We noticed that the credit card was used at the gas station that's not in my state. So that kind of stuff, right? So that's the idea, right? It's what it implies is that event processing has such great value in terms of detecting any kind of fraud, suspicious activities, all of these things that require real time. So then you can respond to that and correct the problems or fix it or solve kind of a criminal activity kind of thing. So that's kind of like complex event processing. Now, the next thing is, then let's go back into a bit into the messaging part, right? Then we kind of talk about event streaming, and then there's also messaging. Messaging itself too, as such, right? Previously, I did talks on reactive systems. We're talking about messaging. Yes, reactive systems also are leveraging on the event-driven type of approaches and dealing with messages that are either delivered as event-driven way, which is like event-driven, very often we're associating with publish, subscribe kind of mechanisms, right? So in a PubSub kind of event-driven messaging, it means that the sender will emit the messages, but the sender doesn't care about who will be receiving the messages. It's basically up to the subscribers who are interested in it will subscribe to these messages, and then they will be getting the messages when the producer produces the messages. So that's more of an event-driven. As far as we know, event-driven kind of implies a sense of, I don't know where the messages is going to, but I rely on a middleman broker to kind of help me with that, to deliver the messages. So that's event-driven. And then there's also message-driven messages, which actually the sender and the receiver would have to know each other. It's more about point-to-point, one-to-one type of communication. So the sender would have to know where the receiver is coming from, what is the address, and that type of stuff. So that's more one-to-one kind of message-driven kind of messaging. Now, the next thing is, let me then talk a bit too about event approach, right? So if we don't use the event-driven approach, and it isn't something new, I mean, as such, we know that events are kind of have been used, for actually quite some time, even though earlier days of event-driven kind of processing. For example, Erlang, if you're familiar, right, in the late 70s, 80s, when telephone systems was kind of the main thing, right, in the technology world, we need to be able to do telephones. And actually, even before that, right, there was already telephones that are in an asynchronous way of communication, right? And of course, prior to that, right, even let's say if it's like before events, you'll be using more like walkie-talkie. You have to only one person can talk at a time, and then it's a synchronous way, right? And when you're done, you say over and you press the button and the other person can talk. So that's more like non-event driven kind of approach. But then of course over time, for example, like Erlang, it makes use of the actor model, which is actually used by Lightband's Akka system. The Akka kind of event or actor model is very good in doing kind of the event driven type of messaging kind of approach, right? Anyway, so the point I'm trying to make is that event driven isn't all brand new, but of course in today's time, it's a lot of things are more sophisticated, right? Because there are also hardware advances, there are virtualizations and multi-core CPUs. All of these things are kind of making the event-driven way of doing things a lot easier. For example, the software is catching up, right? The software is now able to make use of these multi-core machines and kind of do threads and all of these things. So then, for example, even Java, there's no need to only have one thread, right? In your main thread, for example, you can have multi-thread. They're reactive, kind of way of doing things. And then now with Project Loom, if you're a Java person, right? Java, basically with Loom too, it makes use of virtual threads. All of these things are a lot more sophisticated. Okay, so that's that. That's event approach. So you may be wondering then, if we don't use the event approach, what do we do? So basically, kind of counter opposite it would be batch processing. Batch implies you collect all the data and then you process it later, right? It's not like immediate. So that's the advantage of using events, is that everything, the data comes and you want to dynamically react to it and act on it, do things with it right away. But batch, for example, still being used, right, in today's world for example, processing data that doesn't need to be immediately have to kind of have, you don't need any kind of immediate results to that. For example, you are working for big companies and you need to change your employee record. Those things you can wait. There's no urgency to it. If you change your address, usually, right, you find that in your employee system, if you change your address, it doesn't get reflected right away. Usually you wait a couple, maybe overnight or a couple days, then basically then your IT department will process, right, collect all of these changes during the day and then submit to batch processor and process it at the end of the day. So then it doesn't take away valuable computing power during the daytime, right? So that's batch approaching, or batch processing approach, versus the event-driven approach. So I want to set a bit of kind of background to this. Now, then there's also event messaging, the semantics, right, the pattern side of things, which I already kind of brought up earlier when I talk about event-driven messaging, is essentially using a publish subscribe approach, right, the PubSub, or is called producer consumer approach. So basically, the publishing producer subscribers, they are both called the client, right? To client to who? Is basically to the broker. So the broker is basically the main kind of, think of it more like a post office, kind of a postmaster in your post office. And basically, that is the one that's responsible for distributing the messages and receiving the messages. It receives a message from the producer and distribute the messages accordingly to the subscribers. So it's up to those who are interested, the subscribers, will have to subscribe to the messages. And very often, too, we call, you need to label your messages when the producer produces it. So we call it the topics, right? For example, in Pulsar, in Kafka, it is the topic. So topic is a way of labeling your messages accordingly. You can have different topics and different categories, and you can partition your topics. All of these things, as we know, if you're familiar with Kafka, with Pulsar already, right? So you can, basically divide up all of your brokers to different cluster, all of these things. It gets very complicated. But the idea is that that's like the basic kind of approach is PubSub. publish and subscribe type of approach. So broker is the middle agent, and then publisher will publish all the messages to the topic, and broker will take care of things. And there are different rules of how do you deliver, when do you deliver. All of these things can be configured accordingly. And notice that PubSub is not like an implementation details. Basically, it is an architectural approach. So it's up to the software vendor that produces, if they make a PubSub kind of broker kind of architecture, it's up to them as to how they implement it. But the basic concept, again, is about publishing client publish to the broker, and then the subscriber interested in it will subscribe to the messages. So that's how it works, right, fundamentally. And also notice that the advantage of using a PubSub, one of the main advantages is that it helps you to scale very easily. You are decoupling the sender and the receiver. So as you can see, the scalability side of things is makes it a lot easier to do. So I will discuss a bit more in a little bit about this. And then the next way of doing things is basically kind of alongside with the message-driven messaging, is basically the semantics would be, we describe it as a message queue. So the queue is like a form, it's also a form of asynchronous service-to-service communication style, right? But the difference is that between that and PubSub is that message queuing is basically it's one-to-one. So the producer produces the messages, and you only expect one consumer. And then once the consumer consumes the messages, then the messages will go away. And that's kind of the differences. Now, I need to supplement with the PubSub. Very often, to implementation would be after your subscriber gets all the messages will be retained unless it is being acknowledged by the client. That's kind of very often the implementation. For example, in Pulsar, and that's how you do it. So messages does get retained until you receive it and acknowledge that it has been received. Then it will kind of go away or put it into backlog, all of these things. But message queuing in general, once you kind of fetch the messages, then the messages will be gone like that. So both style of semantics helps with decoupling. So it, again, makes kind of like the, processing of messages in huge quantity, much more kind of, able than if you use some older style of, kind of non-asynchronous way of processing things. So that's that. And now, let me kind of step a little further into event streaming, right? It basically is a step beyond just the event messaging part. So we discussed some basics of it. But basically, you want to understand, like, what is driving this change, right? So as we know, we are living in a complex world. And a lot of times, too, we're dealing with data that we want, again, we want data to come, and we want to be able to analyze it and act on it right away. So using an event kind of approach, event streaming, particularly if you think of IoT, Internet of Things, in like let's say an agricultural field, you're collecting data for temperature sensor or water sensor, whatever it is, right? You're collecting all the data. They can have tons of messages coming in, carrying data all at once. So you want that data to be processed right away. So using kind of IoT very often is also using a PubSub type of way of doing things. That's actually event streaming, and that's kind of more kind of realistic to use this approach too, because of the real-time capability that it has. Another way is basically with PubSub too, it enables you to build like data pipelines. Think of, data travel through what we call a pipeline, right? So pipeline and essentially too, you can think of right away if you're involved with AI or machine learning projects, those will be perfect candidate to kind of leverage on event streaming to help you with ingesting huge amounts of data. And then for AI and machine learning, as we all know, right, it's basically you are relying on the data teaching you to build the model. So it's very dynamic. So whatever you have deployed needs to be constantly be redeployed as new data comes in, and you react to it, and then you have your runs through your algorithms and you update your model. So that's actually a very perfect way of leveraging on event streaming to help you to build out this model and to be able to do immediate deployment right away. So that's kind of using it for building data pipelines. Doesn't have to be AI, machine learning, but any kind of data pipelines too can leverage on this kind of mechanism. And another kind of a big thing about doing event streaming is basically scalability too, right? So you can kind of, again, in a field of IoT devices, you can be collecting data. They come in, anytime, and you want it to scale, and you also want it to kind of scale down if you don't need it too. So that type of stuff. So using a kind of a event streaming PubSub type of approach will actually help you a lot. Believe me, if you haven't tried it, try it out, and you realize that it is kind of the most efficient way of managing high volumes of data, the scalability, kind of elasticity aspect of it. So again, this is just a summary, right? Basically, event streaming can watch for events with the system or the application, and then it helps you to subscribe to the topics to see certain event types, right? And then you don't have to get all the messages. You only subscribe to the ones that interest you. And then you can immediately make decisions on the data in real time, not after the event. And it essentially helps you to ingest high frequency of messages, and then it helps you to respond with very low latency. So that's the goal. Now, let me kind of introduce Apache Pulsar now. So what is Apache Pulsar? It is an open source project. Now, basically is owned by the Apache Software Foundation. It was actually created by Yahoo back in the early 2010s, kind of that last decade. And basically, too, Yahoo at the time was processing already, as we all know. I mean, it is an advanced kind of user of all the technology, as in early users of the cloud and everything. And they realized that with all their data, right, they're doing Yahoo services, all of the data that they cannot, they realized that this heavy use of the processing asynchronous style and high ingestion of data needs to happen in the cloud environment. But at the time there was no equivalence of like systems that can handle it, so they developed Pulsar. So as such, it is a streaming platform. It handles the messaging, plus it's a PubSub kind of approach, and also then it handles the cloud kind of data very well. It's basically has the DNA was born with the DNA of cloud native, right? So it contribute well. So they work on this project, and then in 2016 they decided to contribute it to ASF, making it an open source project. And very soon in 2018 it became a top level project. And as such, is cloud native by design. It was born with the cloud native DNA. It's all cluster based, and also supports like what is called like multi-tenancy. You can easily, it manages data. If you want to demarcate all of your data into kind of handling differently, it's already kind of take that into account. And also the nice thing about it is got a simple client API to it. Now let's say you are not a Java developer, no big deal. It doesn't matter, because what it has is the broker is actually written in Java. But the thing is, you can be using .NET client, you can be using Java client, you can be using Go client, Python. And also there are community contribution, for example, like Scala. To somebody asked me, and I realized there is also in our community, there are people contributing to the SDK in Scala too. So you can check out to see what other clients there are. So think of it as really a highly flexible systems. And another kind of a strong point about Pulsar is that it separates out the compute and the storage. So what it means is that, think of it this way, right? I'm processing tons of messages. So very often you need to manage these messages, right? And somehow, your messages comes in, what do you do, right? And if if your network goes away, you need to have some ways of bouncing back right after the network comes back, all these kind of things, right? You have to kind of manage all of your messages, and as you can see, it gets very complicated. Now the thing is that Pulsar decided, the designer decided, well, let's kind of not burden Pulsar to worry about managing all of these huge amounts of log messages, because managing the log messages, can you believe that's already a full-time job in itself? So rather than Pulsar doing it itself, it delegates. And who does it delegate to? To another open source project called Bookkeeper. So Apache Bookkeeper is the one that Pulsar uses, that helps to manage all of the logs and everything. So it separates out. So then Pulsar can then focus on all of the compute side of the messages coming in, the broker of these things. The broker will communicate with the Bookkeeper too. So that's the idea, right? And also too, as we all know, with any kind of distributed messaging systems, messages comes in, and it can be dropped, and if you don't pay attention to it, your messages never arrives, for example. So the thing is with Pulsar is that it has a guarantee message delivery type of mechanism already built in. And as you know, there's quality of service kind of levels, right? Level 0, 1, or 2. It has guarantee at least deliver once, or deliver at least once, or fire and forget, right? All these things. So Pulsar Broker helps to ensure that messages gets delivered. If your network is off, if your client dies, whatever it is, the messages will survive. So that you can rest assured about that. And then another thing too about any kind of messaging systems, right? You need to make sure that messages comes through, all your pipeline. And sometimes too, you want to do some transformation too. Maybe you are reading messages from a source, you need to transform it, whatever it needs to be done. And after that, you deposit it to another sink, right? To what is called a sink. So over there, then you want to, like in between, you want to massage your data, so to speak, right? So in Pulsar, you don't need to use another library. Pulsar itself has what is called Pulsar functions, and it's a small framework in which you actually currently it's only in Java, although there are efforts of increasing its capability, right? There's also Python too. But for example, .NET folks are working on it to support it too. This Pulsar functions framework is proven to be very useful, right, in that kind of usages. And then there's also what is called tiered storage offloads. So basically, your messages could be in your queues or in your storage, right? And sometimes too, it what is called, it becomes cold and all of these things. So it can be offload to long-term storage. So all of these things, Pulsar already has built in to handle all of it. Now, then goes back, right? What is Pulsar? It is unified distributed messaging streaming platform, and it's open source, owned by the Apache Software Foundation. So a couple companies are also like contributing heavily to it, including DataStax, where I'm working with. We have a couple members and PMC members on it. There's also a company called Stream Native. They are actually composed of the original engineers from Yahoo too, and then also a couple other companies, like for example, like Splunk. They're also involved with that, and TIPCO, and a couple others too. So you can look up Apache Foundation website to look up the project to get an understanding of it. And so as far as who is using Pulsar, right, you can also take a look too. So all of these, right, they are kind of major companies, corporations too. A couple of them are actually in China. Some of the communications company, they're also using it. And there's also an increased number of companies that are interested in using it too. So Pulsar is different, wanting to kind of describe a little bit. So Pulsar is essentially has the producer. If you write code, or you have producer, consumer, the broker itself too is already there, but I can show you quickly how can you kind of start going with it, right? So the suggestion is using our data stacks. We offer what is called like Astra streaming. It's already on the cloud, and we provide you with $25 US dollar as a starting credit too, that you can play around with it, and it's very sufficient if you want to do some kind of a personal projects and kind of get used to it too. And basically it's all free, right? And you can launch it onto AWS or Microsoft Azure, or like Google Cloud Platform too. So anyway, so they're the broker, and then there's also Bookkeeper, which actually most of the time you don't have to deal with it directly, because it's a Pulsar kind of managing all of the distributed log files behind the scenes with Bookkeeper, managed by Bookkeeper. And then there's also Zookeeper. Zookeeper will manage all of your cluster metadata, handles the coordination of tasks between the Pulsar clusters and everything. So these, I probably won't get into a lot of details. I realize maybe I'm almost at 30 minutes. So just wanted to quickly kind of point out, right? The Bookie is basically what we call the Apache Bookkeeper. That one in itself is a complex project in itself. Its job is to handle all of the logging messages as such, right? It manages data very consistently and write to disk in a very consistent manner, and keeps the integrity of the data. So you can use Bookkeeper for other things too, but basically Pulsar relies heavily, works hand in hand with Bookkeeper very well, because it helps with, kind of fault tolerant, low latency storage service to guarantee your messages won't get lost, that type of stuff. So Okay, so a really quick summary is that Apache Pulsar is unified solution for PubSub, for queuing, for streaming, and for message mediation and enrichment. And it's cloud. You can use on the cloud or on premise or hybrid. Or if you already have Kafka installation, JMS or RabbitMQ, you don't necessarily need to rip apart all your stuff. You can have Pulsar kind of on top of things and then use it as the mediation in between layer as well. It's totally a very flexible streaming platform. So, and also, I wanted to kind of quickly get into a couple things too. Again, right, key differentiator, right, is basically we separate out between the compute and the storage. I talk about this part, right. Pulsar will worry about the broker with the working with the producer and the consumer and dealing with all of the messaging part, and we let the broker handles the interaction with the bookkeeper. So as you can see, bookkeeper itself will segment out all of your log messages and write it to disk and read from disk accordingly, all of these things. So basically, if you think of it like that, it helps with the scaling. And if you need to add a cluster to it, drop a cluster, a node, all of these things, everything is already automatically being managed for you. So you don't need to worry about it. So that's the pluses. And another thing about this is basically also handles geo-replication, and then also multi-tenancy. I already talked about that. And also a very flexible messaging processing model. So you can actually have different subscription model. So one of which is exclusive, is basically allows you to do message queuing. Is if you want to do one-to-one type of, not the traditional PubSub, you can basically do it on the subscription side, have one consumer assigned to it, or failover shared subscription or key shared is allows you the messages to be processed in the order as it comes and as it arrives and as it being processed too. So those are kind of the things. So, and Artyom, do I have any more time, or am I time up already? So
Mary, we have a couple of questions to you, so I think we can
sure.
just answer them before breaking and switching to another talk.
Sure.
Again, thank you for this talk. It was fluent. You sounded convincing. So even though the developers still might arguing what's better, Apache Pulsar or Kafka, now they have at least to think about Kafka alternatives when designing applications. So there's a couple of questions. Yeah.
Sure.
First, Pulsar guaranteed message delivery, but does it reduce message duplication, or client should implement it?
Oh yeah. So there is Pulsar has this capability of the duplication, the deduplication as well. Yeah, it's already built in too. So it is flexible about that. So yeah.
Thank you. And quick question from Project Loom: is Apache Pulsar provided as a service in any cloud platforms?
Oh, Apache Pulsar provided as a service in any cloud platform? You mean as any kind of cloud provider having it as a service? In that sense,
to
reduce
the amount of overhead to maintain the whole infrastructure or deploying it. So can we have it out of the box somewhere?
Oh, okay. For the different cloud, if I understand your question, then basically too, Pulsar, it's doesn't, or if you're asking if it comes as a service by the different cloud provider, then it doesn't have that. You will have to basically, from a data, let's say from a data stack side, we're supporting, well, data stacks we support Pulsar, but through our product called Astra Streaming. So you can actually deploy your tenants into like different cloud providers. But currently we have GCP or AWS or Azure. So those are the three things. And the thing is, I think if I understand the question correctly, are you talking about the service provider having like maybe a built-in Pulsar to manage all of the messages? Then in that case, not yet, not that I'm aware of, is what if I understand it correctly. Maybe if you folks can want to connect with me on my Discord channel, we can discuss more later too. I want to make sure I understand the questions correctly. So yeah.
Okay, thank you very much for joining us. Thank you for supporting fight of Ukraine for independence, and we really appreciate you talking here today.
Oh, thank you. Thank you very much, Artyom. So actually, if I may ask too, if I still have a minute, so I did not get to the slide that I can um, show everybody how you can connect with me. Should I be sharing that with you? And folks wants to connect with me, or did they already get my slide? So then it has my connection information, right? You know what I mean? Like,
Um, I think we can pick a link to your slides in the chat. Could you
okay,
could you
okay,
could you pass it to the
sure.
technical team? Yeah.
Let me do that. Let me give you the link, because then over there I like to invite people to follow me on Twitter, on LinkedIn, and also connect me with Discord to ask some of these questions in more detail. I think would be good. So let me oops. Okay, let me sorry. I don't think you can see my slides right now, right? Let me go into here.
No.
I'll send it to you, Artyom. Okay, so that's my, can you see my link over there? The bit.ly link, that's the link to my slides. So on the, because I don't have the,
Okay.
I don't
Yes.
have the,
Yes. I
yeah,
see it. I will share in chat. Thank you.
yeah, if you can share, because I don't have access to the main
Yeah. I see.
platform. So
Okay. Sure.
yeah, so folks can please, I invite you to connect with me on my Discord, and I love to have more conversations about this topic. So